Hello Internet and welcome back to the channel. This is an NVIDIA RTX 2080 Ti, a high-end graphic card that came in for repair with a very specific and confusing symptom. When powered on, the fans were spinning at a constant speed, around 40%, and they never changed speed regardless of temp or load. At a first glance, this behavior looked like a hardware failure, but in this case, the real problem was a mix of software, platform compatibility, and a physical issue introduced later. Let's break it down and see what was really going on with this card. The card itself was not overclocked in any way, as MSI Afterburner confirmed that all the clocks were completely stock. However, the system it was installed in was running Windows 11, which was forcing aggressive performance states through software settings combined with a platform compatibility issue. This created abnormal thermal behavior, especially on the memory side, making the problem look like a cooling or hardware-related issue. Because of this behavior, the user attempted to fix what appeared to be a temperature problem by opening the card and replacing the thermal paste. Unfortunately, during this process, a physical issue was introduced with damaged connector pins. So in this case, what started as a software and compatibility problem eventually turned into a real physical defect. For context, this graphic card was installed in a system based on an Asus Sabertooth P67 motherboard paired with 32 GB of DDR3 memory. And honestly, considering today prices for DDR4 and 5, you really can't blame the user still running a setup like this. It is also worth mentioning that this motherboard is roughly 15 years old or 16, and the latest BIOS update for it was released back in 2012. So now, to understand why the fans behave this way, we need to look at how internal feedback and control signals work inside of a GPU. On a modern graphic cards, two types of signals are critical here: the PWM and Tach. PWM state and thermal conditions. Tach stands for timing, address, and control. These signals handle logic, synchronization, and direct control. If Tach signals are completely lost, the GPU enters a fan-safe mode and the fans usually spin at a very high speed. But if the PWM feedback is faulty or incomplete, the GPU can power on, yet it cannot properly adjust the fan speed. As a result, the fans stay locked at a fixed value exactly like we saw on this card. And that's why this card showed such an unusual behavior. Now let's take a closer look and see how this issue was diagnosed and repaired. As soon as I opened the card, I was able to see already the physical problem. The two pins was bent and they also made a connection between them. This can be a problem, but after I was find out the diagram of the pins, I realized that the two pins didn't actually carry high voltage between them. As you can see from the diagram, the pin 1 is the PWM and the pin 2 the Tach, but they are signals. They are not carrying any kind of voltage. So that being said, I started to do some measures around the board. The first step was to straighten the bent pin, and you really need to take care about this step because the pins are very sensitive and they can break. After that, I started to do some measures first on the Tach line, and everything was absolutely fine. But when I started to control the PWM line, especially the line between the IC chip who controls the RPM of the fans, and the pin who was bent, apparently there was an issue. So I started to take each component in that line and try to measure if they are okay or not. And finally, it was really obvious that the resistor near the pin 1 was actually damaged, as the value of that resistor on my meter was actually 0.0 ohm. That's definitely mean the resistor is gone. This was the most easy or happy situation, because otherwise it may possible that a short like that can actually damage the IC chip who control the whole PWM line. So I replaced the resistor, and then I was go to the next step. So after replacing the pads and the thermal paste, it was time to put it back together and starting the tests. And here was the big surprise. Even with the new pads and the issue resolved, the memory was going high wire on the temps. I even moved the card with the 3 P9 fans from RTX, but still this was happening. So I end up doing a mistake. Even if I saw some things are kind of wrong, including the driver version of NVIDIA and some stuff, I trusted my client Windows to do like so. And I would like to show what is happening on my client version of Windows with, for example, Furmark, right? It's a very simple and good example. I must say I never encountered such a thing. Well, now I know. So basically what is happening, the client was given a setting in Windows 11 on performance. What is different in Windows 11 from all other Windows, when you set up on performance, Windows also modify the graphic card specification. In this case, was making the RAM of the graphic card to work on a very high state of frequency, and that's why the temps on the junction or on the memory was basically so high. That being said, I hooked up a hard drive with my Windows 10 installed on it, and after I did that, everything made sense. So now I just swapped the hard drive with a fresh install of Windows 10. Fan control is working, everything is working. I will keep the fans from the GPU at 100% just for the sake of the test. Also, another funny thing, the MSI Afterburner is working normally. I forgot to tell that on my client Windows, the option of automatic or manual, it's gray out. Right? So on my Windows everything is working, and let's see what is happening. I think we can say it's some kind of X files. So let's think. My client operating system, it's a Windows 11 Pro. I spoke with him. He said that he downloaded the drivers, the NVIDIA drivers, from a third-party website, cheap. I don't remember the name, a German website, whatever. He said the first time he had a driver, then he installed the other one. Now remember, the card doesn't have an overclock applied to it. The MSI Afterburner, it's running on the default settings, right? So how can a modified driver, in my opinion, can do such a thing without the user input? This is more very important, right? Without his any kind of overclocking settings. And this is it. This, in my opinion, it's a perfect running 2080 Ti, a perfect one. The temps in load, as you can see, is 51 on the GPU and 67 on the memory, right? So now let's see how it's going inside of a game. My client loves to play Counter-Strike. So we have around 40 degrees with an average of 100 plus frame per second, 140. It should be more. The 280 Ti can do more, but I guess with a little of twitching, we can go there. Everything is fine, running smoothly. I also tested the card with the Arctic P9 fans, and definitely it was much better on temps. It was around minus 10 degrees Celsius, but it's normal because there are 3 fans, and also the P9 can go to like 2700 rotations. So yeah, it was a good test, and you can do this to your card. So the bottom line of this video, it's like this. What you was able to see here was a chain of events. The user which choose a wrong operating system with his hardware because his hardware was very old and incompatible with Windows 11. And Windows 11, when you do a performance setting, he also try aggressive to modify the GPU memory state, which lead to basically fry your memory or the card. This can basically ruin your card. That's all for today. If you like the video, please subscribe, like, and why not even leave a comment. Thank you for today and see you on the next one. GTech 0 out.